Hello guys, welcome to the post-contest discussion of yesterday's Codeforces round. This Codeforces round was at an unusual timing. It was at 1 a.m., but the problems were actually very good. Today we are going to discuss problems A, B, C, and D1, and we can also hover over the idea of D2. Okay, so let's get started, guys. Let's get started with problem A. Bus to Panjamo. So there are n families traveling in Panjamo, and a person is considered happy if another family member is seated in the same row as them, or they are sitting alone in their row. Determine the determine the maximum number of happy people in this optimal seating arrangement. Note that everyone must be seated in the bus. Okay. So guys, what does this problem say? The problem says that you are given such a bus, okay, and let's say size is whatever, its size is n. All right. After this, there are m families, okay, and for each family, you know the size of that family, m1, m2, so on and so forth up till mm. Okay, we want to find an arrangement of people such that maximum people are happy. Now, guys, when are two people happy? When is one person happy? A person is happy if where they are seated, the person seated adjacent to them is from the same family number. If this is from family MI, this person is also from family MI or I to be precise. Okay. Otherwise, that person is happy if he is seated here, nobody else is seated here. Given these two conditions, guys, we need to find out the maximum number of happy people. Now, it is also given that the sum of all the people is smaller than the number of seats in the bus, smaller than equal to. So we don't need to worry about whether the bus will overfill or something like that. So guys, let's get started. Okay. What do we need to do? Consider there are three people in a family, right? Do you agree two of them we can make sit next to each other, and then one we are left and we have to decide what to do? Similarly, if there are four, we can make two sit next to each other, and then there is nothing left. So all these four people are happy, right? So guys, there is a very simple observation. If there are X people in the family, we can make X by 2, okay, floor of X by 2 into two people always happy. How? Because we can form pairs of them and we can make them sit next to each other. Consider there are 7 people in a family. We can form groups like this, which is 7 divided by 2. We can form 3 groups of size 2 each. So 6 people are happy. And now we are left with one remainder. Okay. So guys, what have we learned till now? We have learned till now that we need to, like, for any given X, X by 2 into 2 people will always be happy. Now, for each family, we are going to be left with a remainder. That remainder is either going to be 0 or that remainder is going to be 1. Yes or no? Now, for each family, we just find how many families are there which have remainder 1. And now, after placing all the other people, we are left with, let's say, some rows. All right. And we have to place all these remaining people. Now, since we want to maximize the number of people who are happy, we would like to fill one column first, and then we would like to fill the other column. Let's say there are 4 families which have one person who has not been paired yet. We can just keep these 4 people here, and you can see that all these 4 people are happy. What would happen if this is 5? Then you can see that 5 people are happy, right? But what happens when this is 6? When this is 6, guys, you can see that 4 people are happy. When it is 7, you can see that 3 people are happy. When you can, when it is 8, you can see that 2 people are happy. When it is 9, you can see that 1 person is happy. When it is 10, you can see that no people are happy. Okay. So guys, if there are r rows remaining, all right, after placing the initial people of pairs, okay, if there are r rows remaining and if there are x families, okay, which have one person who hasn't been placed yet, it is easy to see that minimum of x, comma, 2r minus x people would be happy. Now, why am I saying this? Consider x is smaller than equal to r. If x is smaller than equal to r, it means that we can place everyone in one particular column. So minimum of x comma 2r minus x would be x, right? But what happens when x is greater than r? Okay. When x is greater than r, guys, you can see that when it was 6, then currently r is equal to 5, so 2r is 10. So 10 minus 6 is 4. So in that case, this would take over. So when x is smaller than equal to r, like where r is the number of remaining seats, then we have x people happy. But when x is greater than r, basically stating that we are placing people on the second column, then 2r minus x people are happy. You can just substitute this value instead of having an if statement. I hope you guys have understood the solution. Let me just show you the implementation of the same. Okay. So we have initially R, we have a number of people who are remaining, and we have answer. As soon as we take it, this is the rows. So whenever we take in X, I am subtracting X by 2 by the number of rows. So it says that we have already occupied X by 2 rows where each row has 2 people. After that, the number of happy people increases by X by 2 into 2, and then remaining people increases by x modulo 2. If it is even, then everyone is placed. If it is odd, then one person remains unplaced. In the end, we just print answer plus minimum of remainder, comma, 2r minus remainder. That is more or less it for this particular problem. Okay, now moving on to the next problem. Car salesman. Carol is in a car dealership. The dealership has n different models of cars. There are AI cars of the ith model. Carol is an excellent salesperson and can convince customers to buy up X cars as long as cars are from different models. Determine the minimum number of customers Carol has to bring in to sell all the cars. Okay. So guys, what does the problem say? The problem says that, wait, okay. The problem says that you are given an X. Okay, let me use just red for now. You're given an N, you're given an X, and then you're given N numbers, A1, A2, A3, so on and so forth up till AN. So these numbers tell me that how many cars are of the same type. Okay. So there are N types of cars and there are AI cars of the ith type. Now we are also given an X. What does this mean? Carol can pick up at most X cars which are of different type. Maybe one of type 1, one of type 2, one of type 7, one of type 6, so on and so forth. And then and this size should be smaller than equal to X. And then in one move, okay, Karen can sell all of these. We want to find out the minimum number of moves or minimum number of people that Carol needs to sell off all the cars. So guys, this is a good mathematical task. And if you have not solved it, I would recommend you guys do spend some time on it. But let's get started. Okay, guys. So, guys, what does the problem say? The problem says that we are given, like, let's say there is a person. To each person, we just sell at most one car of each type. Correct? So, guys, if we are selling at most one car of each type to one person, do you agree that we are going to need at most max of A1, A2, A3 up till AN moves at least? For example, if my array is 1, 3, 3, 2, we are going to need at least three moves or three people to sell off all the cars, because in the first one you'll sell the first of this type, then in the second move you'll sell second of this type, and so on and so forth. So we are going to require at least max of A1, A2, AN to sell off all the cars. This is the first observation, guys. Okay. Now, what is the second observation? Guys, the second observation is that consider that your optimal answer, whenever you're considering mathematical problems, just try to solve the problem like this. Consider that capital X is your optimal answer. Okay. What is the property of X, guys? So, X is first of all greater than equal to max element of A. All right, max element of A. Okay. Now, guys, if X is my optimal answer, can I say I can also find a way to sell all the cars in X plus with X plus one people? We can all, let's consider we can also sell 0 cars to a particular person. So it's also possible that we can sell all cars using X plus one people or X plus moves, plus one moves. We can also do it using X plus two moves. Yes or no, guys? So we can do for all types of moves x1, x plus 1, x plus 2, so on and so forth, up till infinity. But guys, if X is my optimal answer, are we able to do it in X minus 1 moves? No. Can we do it in X minus 2 moves? No. So guys, we just see that if X is my optimal answer, it's not possible to do it from 0 to X minus 1, but it's possible to do it from X to infinity. So this right here is called a predicate function. Okay. And what we can do on this predicate function is we can binary search. All right. Now, I hope this much is clear, right? The first observation is X is greater than equal to max element. Second observation is we are going to binary search. If this much is clear for everyone, guys, let's move on to how we would exactly binary search, right? Consider we have our array is 1, 3, 3, 2, and we have something like X is equal to 3 here. Okay, guys, X is equal to 3 here. Now, let's say my binary search lands on 4. Okay, it means that I have this type of grid with me. Okay, where I can place my particular cars. So guys, there is a very simple observation. I can keep filling this grid column by column. What, first of all, this is the cars I'm selling to the first person, second person, third person, and fourth person, correct? What do I mean by filling this column by column? If I fill this one and this the second type, then this is the third type, and then this is the fourth type. Filling in this up to down fashion from column to column will always work. And why would this always work, guys? Let me give you a very formal proof that this right here, this the number of rows is greater than equal to max element. Okay. So guys, no matter where I start, okay, let's say I started with the ith type over here. There is no possible way that I'm going to fill up all of these and come back over here again, because this is greater than equal to the max element. For example, here max element is 3. Consider this right here of size 3, right? Even if I start here, type 2, type 2, type 2, you can see that they never overlap. So filling in this column basis from top to down always works. So guys, this is always going to work. Like, we don't need to check if we can place or not place, right? We are always able to place it. Now, what do we need to check? We need to check that the number of columns we are taking, okay, is smaller than equal to our given x. Currently, you can see that we are using 3 columns, but there might be that we would be using more than 3 columns. For example, let's consider what happens when we have 2. So first of all, we can't have 2. Let's have some other number. Okay. But consider that everything was 2 here. Okay. Let's take that particular example. When everything is 2 here, let's consider this. Okay. This of the first type, this of the second type, this of the second type, this is of the third type, this is of the third type, this is of the fourth type. And now you can see that this overflows. So guys, the only thing we need to check is the number of columns we are using is smaller than equal to our given small x. Okay. Now, if that is the case, how do we calculate the number of columns we are going to use? So guys, we know the number of rows and we know the number of elements we are going to place. The number of elements we are going to place is just summation of ai, yes or no? These are the number of elements we are going to place. So the number of columns we are going to take up is nothing but ceil of summation ai divided by the number of rows. Yes or no, guys? Consider we have 7 elements to place and we have only 3 rows. Okay. So if you look at it like this, okay, we have 3 rows. Okay. Here is the first element, second element, third element, fourth element, fifth element, sixth element, seventh element. We are going to require 3 columns to do this. How can we say that? It's just 7 divided by 3 ceil. So this is nothing but 2 plus some remainder. That is why it is equal to 3. So we can always say for a given number of rows, if I pass in a number of rows, the number of columns we are going to require to store all of this is summation ai divided by number of rows. Now we only want to make sure that this is smaller than equal to x. This right here is nothing but a check function. Okay. So guys, if you guys have understood all of this, then that is more or less the solution. But before moving on to the solution, I know like some of you will be like, but there is an O of one solution, Gaurish. There is no required to do binary search. Yes, let me share that as well. So guys, what do we need to find? We need to find the first X, okay, such that ceil of summation AI divided by capital X is smaller than equal to small x. This is nothing but summation ai divided by small x whole ceil. Okay. This formula decomposes to this, like we can just say that this capital X is nothing but summation ai divided by small x ceil. Okay, so this is like seal of this particular function. It can be mathematically reduced to this, but this is a bit confusing. That is why I did not take this up. This more or less brings this down to an O of 1 formula, but something which is much more intuitive is binary search. So let me just show you the binary search solution. So our left is max element, our right is 115, answer is 115. We've also stored sum. So guys, this right here is the formula for seal. If you didn't know this, A divided by B seal is same as A plus B minus 1 divided by B in integer division. So we just have binary search here. Int mid is equal to left plus right divided by 2. If OK mid, then answer is equal to mid, right is equal to mid minus 1. Basically, if it's valid for a mid, then we want to search in the left part of the space, search space. Otherwise, we go to the right part of the search space. In the end, we just print answer. So it's like a big O of log 115 solution plus O of n for pre-calculating max element and sum of all elements. So it'll work in it'll work in around n plus 60 operations. So it's kind of linear. Okay, but as said, you can always use a one-line mathematical formula instead of using binary search. Why I'm covering binary search is that it's a very interesting idea to think around how we could solve this problem using binary search. And it's much, much more intuitive if your mathematical basis is not strong. But if that being said, you can always decompose this formula to just sum plus small x minus 1 divided by x. That would give you the most optimal value of capital X. Great. I hope this much was clear with every one of y'all. If this much was indeed clear with every one of y'all, uh, let's move on to the next problem, which is problem C. So guys, let's look at problem C. Problem C was actually very, very interesting. It was an implementation problem, and it was one of my favorite problems of this contest. Actually, the favorite problem of this contest. So the problem says that there are two candidates running for presidency in Tepito, a rectangular grid of two rows and n columns where each cell represents a house. It's guaranteed that n is a multiple of 3. Under the voting system of Tepito, the grid will be split into districts, which consists of any three houses that are connected. Now, a district will vote for Alvaro or Jose, respectively, if at least two houses in that district select them. Okay. So, Alvaro is the current president. He wants to split the current 2 into n nation of city of his into some districts optimally so that he can get the maximum number of votes. So guys, how do we go about solving this problem? What does the problem say first of all? Okay, the problem says that there is a city of two rows and n columns. Okay, consider n right now here is 3. So it's A, and A, J, J. Okay. So guys, here we can select these three to be one particular district, and we can select these three to be one particular district. So in both districts, we can see that the district votes for Alvaro because the number of people voting for Alvaro is greater than equal to 2. So that is why in this particular statement, we have answer is equal to 2. So guys, let's look at what possible combinations of districts we can have because this is going to play a very crucial role for us. Okay. So guys, consider this infinitely increasing grid. All right. So guys, first of all, we can have this kind of district. And guys, for this kind of district, okay, let me just erase this much. Okay, yeah. So for this kind of district, guys, like we would want to have some more columns as well. Let's say we have two more columns. I think that would suffice. Guys, for this kind of district, we are bound to have this, like this kind of district somewhere in the future. Maybe it is here or maybe it is here. Okay. And in the middle of these two districts, okay, we are more or less forced to have these kinds of districts. Yes or no, guys? If you have this kind of district, you cannot have this kind of district again because this right here would be lost out. So when you have this kind of district, you are forced to have some number of three districts, and then you have to pick up this district. Okay. Now, similarly, guys, let me show you one more grid. All right. Where again we have, let's say 1, 2, 3, 4, 5, and 6. So guys, similarly, we can have this kind of district here, and then we can have this, and then we can have this kind of district. So guys, whenever we are starting out together, okay, whenever I is equal to j, basically if this index is known as I, this index is known as j, okay, if both of these are together, we have like three choices. What are these three choices, guys, to form districts? Okay, 1, 2, 3, 4, 5, 6. So first of all, we can make this adjacent districts where we have one straight line of three houses and one straight line of three houses. Otherwise, we can have this kind of formation, this L formation. Okay. Otherwise, we can have this reverse L formation. Okay. And guys, once we have formed this L formation or reverse L formation, we are forced to take up these kinds of um, particular districts of straight lines until we take up this particular kind of district. Okay. Now, for a particular district, guys, it's very easy to compute if Alvaro is going to win or not. If you know the characters on these cells, the count of A should be greater than equal to 2. Okay. So guys, what have we deduced? For when we start, we have like three choices. Either we can have this kind of district or this kind of district or like straight district. Since we have choices, we are not sure which is the best. Like you can think greedy, but I don't think that would work. So guys, since we have choices and we need to fill a grid, what we can use is dynamic programming to solve this particular problem. How are we going to use dynamic programming to solve this particular problem? Okay, guys. So guys, let dp of I comma j represent that on the first row, we are on the ith column, and on the second row, we are on the jth column. Okay. Now, guys, the thing to notice here is that I and j will be at most one away from each other. What I'm trying to say is that after making this kind of L move, we are forced to make these three moves. Okay. And after making this L move, I is here and J is here. J is one step ahead. This also continues here. If this was index 1, this will be index 2. Now, this will be index 4 and this will be index 5. So, I comma J is never greater, J minus I or absolute I minus J is never greater than 1, or we can say it's always smaller than equal to 1. Okay, similarly, if you take something like this, always you'll make 3, 3, 3, 3. This gap always remains of at most 1. And not to say if you take 3, 3, then they remain the same. Okay. So guys, for every I, you have only like 3 possible J's. Either I is equal to J, or I is equal to J minus 1, or I is equal to J plus 1. So these numbers of pairs are not order of n square, it's order of n pairs. Okay, just keep that in mind. But now that is done, let's try to actually solve this. Let's try to actually solve this. Okay. So for I comma j, guys, we have some possibilities. Either I is equal to j. Okay, guys. Otherwise, I is behind and j is in front. Otherwise, I is in front and j is behind. When this is the case, guys, we have 3 options. Either we can choose this 3 slab as 2 districts. Otherwise, we can take up this district as one, these 3 cities as one slab, or we can take up these 3 cities as one slab. Okay. Now, similarly, when these two are, when I is behind, we can either take up these 3 as one slab. Otherwise, we can take up this one, after which both I and j become equal to each other. I hope you're getting my point. Okay. Similarly, guys, when j is behind, we can either take up this 3 slab, or we can take up something like this. Okay. And sorry, this will be like this. Okay. So these are the choices we have. All right. And if you look in terms of I plus j, this goes to I plus 1 and j plus 2. This goes to I plus 3 and j plus 3. And this goes to I plus 2 and j plus 1. Similarly, this goes to I plus 3 and j plus 3. And this goes to I plus 2 and j plus 1. This goes to I plus 3 and j plus 3. And this goes to I plus 1 and j plus 2. These are the transitions we have for all I comma j, guys. Just keep this in mind. First of all, I want you all to notice that ij cannot be more than one index apart. And these are the basic conditions, right? Either I is equal to j, or I is ahead, or j is ahead. Depending upon what we have right now, we have like 3 choices. Okay. Either we can do this or not do this. Okay. Now, guys, looking in terms of shapes, you can see that if you look at the transitions, this I plus 1 j plus 2 is similar to this I plus 1 j plus 2. Okay. Similarly, this I plus 2 j plus 1 is similar to this I plus 2 j plus 1. Like the shape is different, but the indices you are choosing is going to remain the same. Here we are going to take I plus 1 and j. Here also we are going to take I plus 1 and j. Similarly, if you look at this I plus 1, j plus 2 kind of thing, here we are going to take I, j and j plus 1. Here also we are going to take I, j and j plus 1. So we have only 3 possibilities. When we are at a particular, when you are at 0 comma I and you are at 1 comma j, what either is going to happen? Either we are going to take up um, 2 districts, which is I plus 1, I plus 2, and we are going to take up j plus 1, and j plus 2. After doing this, we are going to move on to I plus 3, comma j plus 3. All right. Otherwise, we have one more choice. What is that choice? We can take I plus 1 and j. So we are going to take I 0 comma I 0 comma I plus 1, and then 1 comma j. This is one possibility. And after that, we are going to move to I plus 2 comma j plus 1. This, if you don't know, it either forms one of these two types. Okay. Now we have one more choice. We can take the other L, which is like this. So this is of type 0 comma I, 0 comma j, 1 comma j, and 1 comma j plus 1. And once this is done, we are going to move to I plus 1 comma j plus 2. Okay. If this much is clear, guys, these are the districts that we formed. Now, guys, what is the score of these districts? Like we are going to another, we are transitioning to another DP state. But what is the score? The score is, guys, how many of them give a vote to Alvaro. So if there are greater than equal to 2 A's in these districts, then you add by 1, otherwise you add by 0. Okay, guys. So these are the three possible states. And let's say this returns, you are calling DP of I plus 3, J plus 3, you are calling DP of whatever, and you're calling DP of whatever. Okay. So let's say this returns integer X, this returns integer Y, and this returns integer Z. Then we would like to answer, then DP of I comma J would just be maximum of these three values. Yes or no, guys? Correct? So that is more or less all we need to implement. And then our final sub problem would just be dp of 0 comma 0. Why would be dp of 0 comma 0, guys? Stating that we are starting over here and then we have three choices. Either we can take up this, or we can take up this, or we can take up this kind of slabs. So this is the dynamic programming solution. The only thing right now we need to take care is how do we actually store these pairs. So guys, since we want to store these pairs and each can go from any number between 1 to n, although the number of pairs we just discussed is order of n, but like how do we store them? We can just use a map of pair of int comma int as the key, and we can just use a map as a DP, right? This is a very infamous trick that whenever you have very sparse things and you want to store them, and you can't really use a vector because that would be a lot of space, in that you can use a map. So that is more or less it for this particular solution. Let me just show you the implementation of the same. Okay. So guys, this is the check function which returns 1 or 0 depending upon if Alvaro is getting a vote or not. So if I pass in three coordinates, if a dot first, a dot second is equal to a, then it returns 1. So the sum of this, so the number of times a came should be greater than equal to 2. If it is greater than equal to 2, this function returns a 1, otherwise it returns a 0. Okay. Now guys, if I is equal to n and j is equal to n, we return 0. Okay. Otherwise, if you look at it, what are we doing? If I is equal to n, j is equal to n, basically we reached out of the grid, then we are returning 0. Otherwise, if dp I comma j was already present, if it was already calculated, we return dp ij. Otherwise, we have three options, guys. What did we say? We can either do this I plus 1, I plus 3, j plus 3 transition, or I plus 2, j plus 1 transition, or I plus 1, j plus 2 transition. Now, there are some conditions, like if I maximum of I plus 2, j plus 2 is smaller than n. Basically, if we are only able to make these slabs, like it doesn't make sense that I plus 2 does not exist, right? Or j plus 2 does not exist. So if both of them, like making the slabs is actually possible, then only we make the slabs, and we are just passing the coordinates of the slabs or districts here. And we are calling I plus 3, j plus 3. Otherwise, it's 0. Now, option 3, what does it mean? When can we actually form the first kind of slab where we are taking I and I plus 1? So either I is equal to j, as we discussed, right, guys? When both the pointers are at the same position, we can either take this particular L up. Otherwise, we can take the L up when already we have formed its complement L. I hope you get my point. Like if we have formed a sleeping L, then we have to take a reverse L. So only when I is equal to j or I plus 1 is equal to j, then we can take up this particular L. And similarly for the other kind of L, we can only take it up when I is equal to j or I is equal to j plus 1. So we are returning the number of things for each option, and then dpij is nothing but maximum of what we get from option 1, option 2, and option 3. It's like an O of n log n solution. Why log n? Because we are using a map, but I'm pretty sure this can be optimized to linear time by implementing it without a map. This is one of the cleanest ways to implement this particular solution. So I would recommend you guys that you do look up this solution and try to understand how it was implemented. Otherwise, implementing this problem would be a menace and it can take up a lot of time. Okay. So I hope this problem and solution is clear for every one of y'all. If it is indeed clear for every one of y'all, let's move on to the next possible problem, which is D1. And D1 is actually not so hard, guys. Let's have a look at D1 and see what the problem asks us. Okay. The problem is called asesino. I think it means assassin. Okay. So there are n players. Each player is either a knight, knave, or an imposter. We know that there is exactly one imposter, but there can be any number of knights or knaves. We are given n plus 69 queries, and in each query we can print I and j, which basically says that if the ith person is asked if jth person is a knight, then will it give me true or false? So what is a knight? A knight is just a knight. Okay, it's a noble person. Knave is a person who lies. So if you ask a knave if a knave is a knight, it will say yes. If you ask a knave if a knight is a knight, it will say no. What is an imposter? An imposter is someone who everyone else thinks is a knight, but is actually a knave. So if you ask anyone, if you ask a knight if the imposter is a knight, the knight will say yes. If you ask a knave if the imposter is a knight, the knight will say, the knave will say no. But if you ask the imposter something, the imposter is always going to lie. Okay, guys. So we'll have to ask these kinds of queries, and then we have to more or less answer this in n plus 69 questions. Okay. So guys, this is a very good problem. What does the problem say? The problem says that you are given an array where people are standing. Okay. These are n people. Okay. I'm just going to draw 3 of them. So secretly, there is an imposter standing in between. Okay. And all other people are either a knight or a knave. All right. And this right here is the imposter. Okay. We need to find which index the imposter is based on queries ij, where you basically ask the ith person if the jth person is a knight or not. So whenever you're given such kind of problems, guys, the your task is just to make a truth table. Okay. And I think the truth table is already given, but for our sake, we'll just make it again. So let's say we have a knight. Okay. And you have a knave and you have an imposter. Similarly, these will be the people who will be answering it. So you have a knight and then you have a knave and then you have an imposter. Okay. So guys, when you ask a knight, let's solve for both sides. Okay. If you ask this knight if this is a knight, you will get true. If you ask this knight if this is a knight, you will get true. Okay. Now, if you ask this knave if that knight is a knight, you will get false. And if you ask this knight, if that knave is a knight, you will get false. Now let's consider knight and imposter. If you ask the imposter if that knight is a knight, you will get false. But if you ask the knight if that imposter is a knight, then you will get true. Similarly, let's solve it for a knave and knight. So in knave and knight, you will get false and false, guys. In knave, you will get true and true. Okay. Now here, this won't exist, but let's for knave and imposter, guys. When you ask the imposter if the knave is a knight, you'll get true. And when you if the knave, if you ask the knave if the imposter is a knight, you'll get false. Similarly, for imposter comma knight, you will get false and true, or true and false, whatever. You'll get true and false. And for imposter and knave, you will get false and true. Okay. So guys, there is a very interesting thing. Whenever you have two pairs of people and you ask I comma j and j comma I, these two kinds of queries, only when it has an imposter with it, then the two answers differ. Otherwise, if you ask knight comma knight or knight comma knave or knave comma knight or knave comma knave, the answer always remains the same. So guys, our approach is very, very simple. What is our approach? Let's say we are having n people. Okay. What are we going to do? We are going to pair these two up, these two up, these two up. Now for all these pairs, we are going to ask these kinds of queries. Okay. Now, if both of them return true, true, or false, false, it is fine. It means that both of them are innocent. We can let them go. But let's say one of them returns true, another one returns false. Then we know, guys, that one of them is the imposter. An imposter with an O. Okay. So, guys, we know that either this guy is the imposter or this guy is the imposter. So, how can we confirm which one is the imposter? So, guys, very simple. We can just, for this particular person, either take the previous man or the next man and ask the same kind of queries. Let's ask these kind of queries. We know that this person is innocent. So now if again this returns true and this returns false, it means that one of these two are imposter and one of these two are imposter. It means that this is the imposter. But if both of them return true or both of them returned false, we know that this isn't the imposter, which by default makes this person the imposter. So guys, our approach is very clear. We just divide in groups of two. And once that much is done, we just ask I plus 1, and then I plus 1, I. If both of them are same, then it's fine. If both of them are not same, then we take up a third person and ask for I. If then both those are same, like I comma third person and third person comma I, then we can say that the ith person is not the imposter, I plus 1th person is the imposter. Or if both of them are not the same, we can say that the ith person is the imposter. This is a very nice problem. It required a bit of thinking and it was much easier than the previous dynamic programming solution. Let me just show you the code for the same. The code for the same is not actually quite hard. It's very easy to come up with. So guys, this is my ask query where given two indices ij, you print it out, you take in the result, return the result. Now, I have my initial answer is n, considering that the last person is going to be the imposter. Now, we start from I is equal to 1, while I plus 1 is smaller than equal to n, because we are going to ask I and I plus 1 kind of queries, and I plus equal to 2. So, if ask I comma I plus 1 is not equal to ask I plus 1 comma I, it means that one of them is the imposter. If they are the same, then this entire if statement gets skipped. We go on to the next pair. But if it's not the same, then we are going to pick up a random third element. So if I minus 1 is actually greater than equal to 1, if the previous element exists, then we are going to take up the previous person, or we are going to take up the next person. Both people are innocent, like both people are either a knight or knave. So we don't need to care much. After this is done, we ask j comma I and I comma j, if they are not the same, we can say that the imposter is at index I. But if they are indeed the same, we can say that the imposter is at index I plus 1. Okay, so it's very simple. And then for D2 also, guys, like we solved it for D1. For D2, I'll give you a small hint, like we won't be discussing the solution, but the only small hint is that this takes up n plus 2 queries in the worst case. Okay, we need to optimize this to n queries. Okay, that is the task. If you are able to successfully reduce 2 queries, okay, then in that particular case, we can um, solve the problem. Like the biggest hint for D2 is that f of n is equal to n. Okay. So I guess that is more or less it for this post contest discussion. I hope you were able to understand all the problems. And also, guys, if you did give the contest, kudos to you. You gave the contest at 1 a.m. Okay. And if you're up solving, I hope you are able to understand the problem for which you didn't come up with the solution. So see you guys next time. Till then, bye bye. Have a great day ahead and keep grinding.